Okay, hey, welcome back. This is now 6.6, and we are working with solving quadratics by factoring. So section 6.6, solving quadratics by factoring. So what is a quadratic? A quadratic is of the form ax squared plus bx plus c. Before you would just be given this expression. Now we're going to see it in equations. So you'll see an equal sign somewhere, and usually the standard form, it'll be set equal to 0. Okay, so this is kind of the standard form of these equations. So you can actually use these ideas that we're teaching here in other classes, like trig. You can use it in trig. So solving these. The main principle you're going to be using to solve these things is the zero product principle. A lot of the principles in math, because we've been doing math for such a long time, are kind of silly at this point, but there are different kinds of math where you would have different principles, so we need to kind of remind you that this is a principle here, if you ever decide to keep taking more and more math. But anyways, if you have a times b equaling 0, then guess what? Either a is equal to 0 or b is equal to 0. Okay, it's kind of like a simple idea, I guess. So we want to apply this fact to solve equations, these quadratic equations. So let's look at a bunch. So first we have x times x minus 3 equals 0. So there are two terms here. It looks like there's like a ton of symbols, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 symbols or something, little marks on the paper. When it comes to factors, though, there's really only two factors, right? There's those are the things that are being multiplied by each other. So here's a factor and here's a factor. Inside the second factor, there's a difference. Right? There's two terms in that difference, but we wouldn't refer to those two terms as factors. Okay? You only use the word factors when you're talking about items that are being multiplied by each other. Terms are things that are being added together or subtracted together. Okay? So here we only have really two factors, and to apply the zero product principle, we just set them each equal to 0, and that gives us our answers. So one of our answers is automatically 0. The other one, I'm going to have to do a little bit of work. I have to solve this equation, and I get x is 3. Okay, so those are my answers. And my math lab, they'll want you to give your answers as a solution set, and that just means do some curly brackets and put the numbers inside those brackets. Okay, so the solution set is 0, 3. Okay. Okay. Let's got another one. Okay, so again, two factors here, x plus 7, and then the other factor, 3x minus 2. Okay, so we set each equal to 0 and solve those two equations. And so here, move the 7 over. So one answer is negative 7. Here, I have to add 2 to both sides, and then I'll divide by 3. So our other answer is 2/3. Okay. And you don't always need to have two different answers. It's not always going to be the case. It just happens to be the case here. Let's get another 8 times x minus 5 times 3x plus 11 equals 0. Okay. This time we have 1, 2, 3 factors. Okay. We could set each equal to 0. It's kind of silly to set the 8 equal to 0, but you'll see the book probably does it. 8 will never be 0. 8 is not equal to 0. So that doesn't really give you any solutions. That's not part of the answer. Okay? So no help there. The solution will come from these two terms. The x minus 5, that could potentially be 0, and the 3x plus 11, that could potentially be 0. Okay, so add 5 to both sides here. On the second guy, subtract 11 on both sides. and then divide by 3. Okay, so our two answers, 5 and negative 11/3. Okay. These first couple problems, you'll see them in the homework, and they're kind of easy because they're already factored. But in the standard form you see up here, they're not usually factored, right? So let's look at some of these problems where I actually have to factor to solve it. Factor first. So in the real world, everything's easier, is kind of the point. Or sorry, in the real world, everything's harder. Okay. It's kind of the point of this stuff. Okay. So I have to factor first. So I mean, initially, even before I start factoring, I want to make sure everything, and I'll talk about sort of a general strategy here in a second, but I want to make sure everything, all the variable and the constants and stuff are on one side, and then I have a 0 on the other side. Okay, and they kind of already set it up for you so you can see it's kind of already half done. Then I want to factor, okay, using all of your methods from 6.1 to 6.5, right? Using all those methods. So here there's an x plus, and then two numbers that multiply by 6 but add the 5. So 3 and 2, right? And that equals 0. Then you take each factor and set it equal to 0. And solve. And there's our answers. Negative 3 and negative 2. Let's get one more of those. Okay. I got 0 on one side, the quadratic is on the other. Now I want to factor. It's like 7 and 6. Okay, I want the bigger number to be positive. Set each equal to 0. And those are your answers. Okay, great. Let's talk about a general strategy then. Okay. So for dealing just in general, how do I approach these types of questions? If I were going to write up maybe a computer program, I would want to have the strategy outlined. So the first thing you want to do is set it equal to 0. Okay, so write it in the form ax squared plus bx plus c equals 0. Secondly, you want to factor, and not just any factorization, you want the complete factorization. Okay. Thirdly, then apply the 0 factor property. So if a times b equals 0, then either a equals 0 or b equals 0. So we want to apply that. Fourthly, solve the equations in step 3. And then fifthly, if you have time, check your solutions. And I am notorious for not checking. I should, but I am getting older, so I forget. Anyways, let's take a look, okay? Let's take a look. So here's an example. X squared minus 11x equals negative 10, right? Okay, so first thing I notice, it doesn't have 0 on one side. So I'm going to add 10 to both sides to put it into our standard form. Okay, now I'm going to factor the thing. So it looks like it's a x minus scenario. And then 5 and 2, nope, 10 and 1, yep. Then set each factor equal to 0. So it looks like we have x is 10 and x is 1. And those will be our answers. And you could check them if you want to. I generally don't. But, if you did everything right, it should be right. Let's look at just a whole bunch more of these examples, and then as usual, we'll move on to my math lab and look at the hard ones. Okay. Okay, so here we have x squared minus 6x equals 0. This one is already set equal to 0, so we're good there. I need the factor completely, so I have to pull out the GCF. And then you set each factor equal to 0. So one factor is x, the other factor is x minus 6. And so 0 is one answer, and then moving the 6 over, 6 is the other answer. Let's see what else. X squared equals 8x. If you've not been paying attention and you're not watching my lectures on the test, I bet this is what I will see. So a lot of people like to divide both sides by x and then just say x equals 8. Okay, you have not followed the rules. Okay, that's bad. This is bad. You didn't follow the rules. Okay. It doesn't say divide by anything. What is the first step? Write it in the form. You want 0 on one side. Okay, so you move the 8x to the left side by subtracting it. And now it's equal to 0. And now this next step is to factor completely. So I can factor out an x. And then you set each part equal to 0. And actually, there's two answers, not just x equals 8, but also x equals 0. Okay? You would lose that answer if you divided by x, because you've assumed when you divide by x that x is not 0. Because if you divided by x, then x can't be 0, because you can't divide by 0. Okay, so that's why we don't divide by x. Unless you explicitly say it and then go back and check it. But no, just follow our program. Okay? Okay. Let's get another one. Okay, so again, set it equal to 0. Move the 30x, move the 25. I get 9x squared minus 30x plus 25, 0. This is like a special form, right? Maybe 3x and 5, 3x and 5, because of those perfect squares. It'll have to be minus, minus, and then check it, make sure it works. So 15 for the outer, 15 for the inner, yeah. Then set them equal to 0. And you see, this is what's going to we'll later call a repeated root. Okay. For now, you don't have to write both. You don't have to write it twice. You just have to write one of them. So it would be 3x equals 5. So x is 5/3 is your answer. You don't have to solve both of them. That would be silly. Some of these are a bit kind of deceptive. Like it looks like a problem above. Like for example, x times x minus 3 equals 18. So it looks a lot like this example at the top left that I'm circling in blue. It looks similar, but there's a big difference, isn't there? The big difference is that 18 on the right. And that is a troublemaker. Okay, that throws a wrench into the machinery. That sabotages everything. You can't just ignore that fact. You have to do some work. Okay, so you're just gonna kind of have to go in reverse a little bit. I'm gonna distribute this out. I get x squared minus 3x. Move the 18 to the other side, so minus 18 equals 0, and then factor it. There's no way around it. There's no like special kind of quasi-factorization, like you could set x equal to 18 and x minus 3 equal to 18. That won't work. Okay? You could try it. I encourage you to experiment. Okay? Of all the things in life you can experiment with, math is one of the best. Anyways, plus minus, you want the bigger number to be negative. So 6 and 3 we're thinking. Make sure that works. X squared minus 6x plus 3x is minus 3x, and then minus, okay, it works. Set each part equal to 0. And we get x is negative 3. x equals 6 as our solutions. Another one like this, and this will be the video quiz. Video quiz, video quiz, video quiz. This is the second video quiz from video homework number 2. Okay, and this video homework will only have 2 questions in it. So basically, just 6-5 question, 6-6 question. You'll turn that in. Would I say so on Blackboard? The first video homework quizzes were due on Tuesday, June 8th. Okay, and then the next 2 video quizzes will be due on the 15th. These next 2 problems will be due on the 15th, 6/15. Okay. So, anyways, I think is that right? So this is 6-1, right? And the first video quiz is due on the 8th. Yeah, and I believe it's the 15th, but I'll put it on Blackboard to remind you. Okay. Anyways, video quiz. X minus 3 times x plus 8 equals -30. So again, this is one of those tricky ones. You think, oh, I could just set x minus 3 equal to -30, x plus. No, that's not. We don't have a property like that. There's no non-zero, whatever we call it, non-zero product principle. We don't have that. So you have to do some work. You're going to have to FOIL first. X squared outer plus 8x inner minus 3x minus 24. Combine like terms. Move the 30 to the other side. And then you could factor it. Okay? So they try the trick here. Looks like x plus 3, x plus 2. And make sure it works. X squared plus 2x plus 3x is 5x plus 6. Yeah, it works. And then set each equal to 0. And solve. So our answers will be -3 or -2. Okay, so let's move on to my math lab, and we'll see a whole bunch of applications and that sort of stuff. Some of the harder questions. Okay. X cubed minus 81x equals 0. Looks like I factor out an x. X squared minus 81 is 0. And then that's a difference of squares, so we're factoring completely. So x is 0, x is 9, or x is -9. Okay, that'll be our solutions. And then they want the solution set, so you just write 0, comma, -9, comma, 9. So don't forget the commas. Next. Okay, this one looks rather simple. So you gotta factor out a y, right? So y cubed plus 8y squared plus 15y is 0. Factor out a y. You get y squared plus 8y plus 15. 0. Factor this then, y plus 3 and 5, right? Y plus 5. 0. So y is 0. Y plus 3 is 0. So y is -3. Y plus 5. Or y is -5. Okay. Ooh, look at that guy. I was looking a nuisance, to say the least. X minus 2 squared plus x squared equals x times x plus 58 minus 46x. I need to set it equal to 0. And not only that, I'm going to want to factor it. And right now, it's such a mess. I'm just going to FOIL and distribute everything and then combine all the like terms on one side. Okay, so first off, x minus 2 squared is the same as x minus 2 times x minus 2. So I'll just remind myself of that. On the right, I'm going to distribute x squared plus 58x minus 46x. I'm going to FOIL these guys out. So I have 3 times x squared minus 2x is minus 4x plus 4 plus x squared equals x squared. Combining like terms, 58 x's minus 46 x's is 12 x's. I'll distribute here. And then I'm going to set it equal to 0. So if you subtract x squared from both sides, the x squared will be gone. And then subtract 12x on both sides. And you're going to get 3x squared minus 24x plus 12 is 0. Okay. Factor out of 3. 8. I don't think that'll factor. Just making sure I copied it correctly. Oh, I see. Oh, I'm so sorry. It's x minus, I copied it down wrong. So this will be 3 and 3, and this will be negative 6x, and this would be 9. And this would be minus 18, and this would be 27. And then the x's would be gone. 18 and 27. This is 27. And this would be 0, carry a 1, so 30 minus 30. And then this would be 3 times x squared minus, I'm so sorry, 10x plus 9. And then that looks like I could factor it. So 3 times x minus 9, x minus 1. The 3 doesn't give us anything, so it's just x minus 9 is 0 or x minus 1 is 0. If you wish, you could go 3 equals 0. Nope. All right, so x is 9 or x is 1. So here, 9, not 1. Bummer, right? Okay. Oh, some story problems. So ball is thrown straight up from rooftop. Our formula, h of t is negative 16t squared plus 20t plus 300. Describes the ball's height after 2 seconds. The ball misses the rooftop on the way down, eventually hits the ground. The graph of the, okay, so when does the ball hit the ground? The graph of the formula is shown with tick marks not labeled on horizontal. How long will it take for the ball to hit the ground? Okay, so you want to know when does the ball hit the ground? So what is the height when the ball hits the ground? That means when is h equal to 0, right? When is the height 0? So you just take the 0 and replace this h of t thing with it. And then what we're going to do is solve for t, the time at which the height will be 0. There's going to be 2 answers. And you can see over here on the graph, one of the answers is if you kind of continue this shape here, it's going to be over here in the negative part, in the negative time. But we don't care about that because we're in physical reality, right? Okay, so we can find the answers by factoring. So I'm going to factor out a negative It's like 4 goes in all of them. How about 8? No, just 4. It's probably the greatest. So I end up with 4t squared. This, pulling out the negative, will flip the signs. Negative 5t, and then plus, or it'll flip the sign, so minus how many quarters are in $3? 12 quarters. And then we'll try to factor that. If it doesn't factor, that's usually means we did something wrong, like copied it wrong or something. Okay, so I'm thinking 2t. I'm hopeful it's going to be 2t and 2t, and then maybe like 6 and 2, something like that. So 4 and 12 new. But, 6 and 2 and 4 and 1, maybe. So like 4 and 1 over there, and then 6 and 2. Put the 6 in right here, and then the 2 out there. So it'd be 8 and 6. That ain't gonna work. I'm starting to think we did something wrong. 6 and 2, 4 and 3, maybe. So there's a lot of possibilities here. So maybe like 4 and 3. 4 and then 3 here. So that would be 12. Minus 4 would be 8. So that's not going to be good either. 16 minus 3 is 13. That's not going to work. Well, the most annoying factorization ever, right? And then you hope you got it. You didn't make a silly mistake somewhere above. And anyways, the signs have to be plus minus. I'm going to have to do this the long way. So we're thinking, I bet you 2 and 2 is where it's at, but I don't know. And then let's go 6, and I was hoping to get lucky, but I didn't, right? So 12 and 4. 12 here, and then 4 here. 12 minus 4 is 8, so that won't work. If you just switch switch the 6 and the 2, you're going to end up with the same thing because of the 2 and the 2. So maybe anyways, 2, how about 4 and 3? Right? So here you get 8, and here you get 6. So 8 minus 6, that ain't going to work either. Starting to think I just made a mistake. Let's do 4 and 1s. It's 12, and but that's going to be way too big. 12 and 1, right? How about 4 and 1, and then 12 and 1 won't work because it'll be 12 minus 4 is 8. Let's see what else. You can almost approximate with little tick marks. 1, 2, 3, 4, 5. 5 can't be one of the answers. Maybe I did I screw up 4 and the 300? I don't think so. Oh, 100. Oh, that is the mistake. How many times does 4 go on the 300? 120, right? It's not $3, it's $300. I try to be clever here. 4, it goes in the 30, probably like 7 times. Maybe 28, 75. Okay, so that's what I don't know what the heck I was thinking. I apologize. So that's 75 there. No wonder it wasn't working. So yeah, probably 5 is going to be one of the answers then. So I'm going to bet t minus 5, and then 5 and the 75 was 15 times, and then I guess 4. Right? That's not going to give me a nice answer. 4t. The middle number won't be right. So 15. Yeah, well. So 4t squared, first outer minus 20t inner plus 15t last. minus 75. Yeah, that works. Okay, set the parts equal to 0, so 4t plus 15 equals 0. 15. And this is the answer that doesn't work, right? Because time in our universe doesn't go negative. And then t minus 5 equals 0. So it looks like the answer is 5. 5 seconds. Sorry about all the... If I take any shortcuts, I always end up paying with a little mistake. Anyways, each check mark on the graph, because it's 1, 2, 3, 4, 5, each one has to be 1 second. Another one of these, maybe I can redeem myself. Ball is thrown straight up from a rooftop that's 80 feet. Formula gives the height and time at time t. So negative 16t squared plus 6t plus 80. The ball misses the rooftop on the way down. The graph of the formula is shown. Determine when the ball's height will be 70 feet. Identify the solution as a point on the graph. Okay, so I want to know when will the, so it looks like it's going to be t equals 1, right? Just by looking at the graph on the ball's height. So I want when will ball be at 70 feet? Okay. So what you do again is replace h of t here with 70 and then solve. All right, so I'm going to move everything to the left side this time. So 16t squared minus 6t minus 10. So 70 minus 80 is minus 10. I can factor a 2 out of everything. And judging from the graph, it looks like one of those solutions is t equals 1, right? So you know one of the factorizations will be t minus 1 just because of that. The other, I assume, will be 8t minus plus 5. Right? Make sure it works. So you get 8t squared first, the outer, plus 5t, the inner minus 8t, the last, yeah, it works. Okay, so the two solutions, t minus 1 is 0, or 8t plus 5 is 0. So t is 1, or 8t plus equals negative 5, t is negative 5/8. We throw out the negative solution because time in our universe is not negative, and we hold on to t equals 1. Okay, so 1 second. Plot the point that represents, it's right here. Oh, another one of these. Explosion causes debris to rise vertically with an initial velocity of 72 feet per second. Then they give you another one of these position formulas. When will the debris be 32 feet above the ground? So again, you're just setting the height formula equal to the height that they want a time for, right? So in this case, you're going to be setting that formula for h equal to 32. And then solving. So I'll move everything to the right side. So add 16t squared to both sides, subtract 72t from both sides. And then I'm going to flip-flop sides. So instead of writing equals 0, I'm going to put the equal 0 on the other side, just so it looks more standard. Okay, I can factor out a 2. Can I factor out a 4? Be a little more careful. Yeah, sure as heck looks like it. So I can factor out a 4. Can I factor out an 8? Sure seems like it. And can I factor out 16? 16 go in the 72? I don't think so. So let's just factor out the 16. Or sorry, the 8. And then maybe we'll see we can factor out more. 2t squared minus 9t. Yeah, that's as good as we're going to get it. And then factor this thing. So we'll have 2t has to be minus, and t, and then probably 4 and 1, right? Make sure it works. 2t squared minus t minus 8t is minus 9t, so that works. So 2t minus 1 equals 0, so 2t equals 1, t equals 1/2. And then t minus 4 equals 0, and then t equals 4. Yeah, so there's two answers this time. 1/2 seconds when it's going up, when the explosion debris is going up, and then when it's coming back down at 4 seconds. Oh boy, another one. This formula, this quadratic is modeling spending in billions of dollars, X years after the year 2000. They graphed it over here for us. If a traveler spent 84 billion in 2003 and 2005, identify this information as points on the graph. 2003 would be right here, because the x-axis represents the number of years after 2000. So that hits the graph right here. And then that's one of them. Plot the point that represents 84 and 2000. So that's one answer. Plot the point that represents 2000. So you go over the 5 for 2005 and then go up to the graph. Is that it? Oh, okay. Some animal questions. An endangered species protection formula. How long until the population is 4850? Okay, so you just replace P, the population, in that equation, because that's the population equation, with 4850. So instead of writing P, write 4850 equals negative 10x squared plus 345x plus 2400. Okay. I'm going to move everything to the left side. So I have 10x squared plus 345 plus 2450 equals 0. You can divide everything by 5. It's like 69x, lost my x. Just double check. Let's just use a calculator, right? Let's stop it. This isn't exactly putting hair on my chest. 345 divided by 5. 69, 24. I have O divided by 5. 490. Equals 0. Usually 49 and 10 turns out to be a good guess for these types of problems. 49 and 10 for factoring 490. Just from my own experience, I don't know if it's the people that are writing the problems kind of use that trick. But, anyway, you know, it's plus, and then it's probably 49 and 10 or 10 and 49. It's 49 and 10 over here will give you 20x plus 49x for the inner and outer terms, and then that'll do it. Anyways, seems like I screwed up the signs. Yeah, it should be minus, and then plus. This has to be minus. Sorry, gang. So this will be minus. So we have 2x minus 49 is 0, so 2x is 49. In other words, x is 49 halves. Or x minus 10 is 0 and x equals. So how do I know? Can I use 49? No. If you read the question, it says x has to be in between 0 and 12, so the answer has to be 10. You throw out the other answer because it's not in that interval. Some weird parking lot question. Rectangular parking lot length that is 2 yards greater than the width. The area is 288. So just remember, area is basically length times width. So in this case, our area is x times x plus 2. And they even tell us the area is 288 square yards. Okay. So we want to find the x value, which will be the, I guess maybe that's the width. If you look at the picture there, and then x plus 2, I guess we could call that the length. I guess usually this dimension is length, I guess, and then this is the height. But they even tell you in the story problem, right? The length is 2 yards greater than the width. So the length has to be the x plus 2, and then the width is the x. So there shouldn't be any guessing, is what I'm kind of getting at. All right, so it'll come down to solving this equation. So you got to set it equal to 0. Okay, so we got x squared plus 2x. Subtract the 288 over to get it equal to 0. Okay. Then factor it. So x and x plus minus 288 divided by, how about 24? 24 and 12? No. And then you can kind of factor it and just shuffle the numbers around to get a nice answer. 24 is 6 and 4. This is 6 and 2. So maybe, I don't know. 36 and 8 won't work. How about divided by 18? 288 divided by 18. Yep, 18 and 16. So you want the bigger number to be positive. And we can't use the negative answer, right? So x equal negative 18 because we're talking about dimensions here. That won't work. So the width must be 16, and then the length is 2 plus that. In other words, 18. The width is 16. And we're talking about yards. And then the length is 18. One more. Fish has a triangular tooth, so some megalodon shark or something like that. Height is 1 centimeter longer than the base. So if the base is x, then the height will be x plus 1. The area, so the area for a triangle is 1/2 base times height. And in this case, the area is 45. So 1/2 the base is x times the height is x plus 1. Okay. Look, rather than distributing this 1/2 x into this, I'm going to multiply both sides by 2. Okay, that will get rid of that ugly fraction. So on the left side, I'll have 90. On the right side, 2 times 1/2 is just 1, and then 1 times x is just x. And I'm going to distribute and set it equal to 0. Move the 90 to the other side, and I'm going to flip-flop sides real quick. And then hopefully factor 9 and 10. Bigger number is 10. Okay. And then we'll throw out the negative answer. So we can't use that one. Okay, so apparently the base is 9 centimeters. And the height is 10 centimeters. Okay, so that should do it. Thank you for watching, and we will see you next time.